Greetings to all and welcome to the next video tutorial of the playlist Forming HyperForm. So in this video tutorial we will see how to perform multi-stage deep drawing analysis of the sheet metal component. Why multi-stages are required for the deep drawing process, those all things I explained in my previous video of the playlist Deep Drawing Process Simulation. So such multiple stages analysis, or we can say multi-stage analysis, are quite difficult, critical not in terms of CAE, but such analysis need very accurate and precise geometries and tool designing. If there is any small error or small change in tool design, the complete simulation result will be changed. Even the small clearance between tooling, punch and die and punch and binder, that may completely change your simulation result as well as manufactured component. We will see one example on it, like if we have some changes in the tool design, how the results will be affected. So this example I took from one research paper, and the link for the research paper is given in the video description. So this is the initial blank shape that we are going to be manufacturing the final component. Final component will be look like that. So now let me show you the animation. Just hit on the play button. This is the first stage forming. After first stage forming, second stage, then third stage, and this will be the final fourth stage. So you can see this is the fourth stage final component. Also you can go for rotating, or you can go for some standard view. Here also you can go for some standard view, and again go for play the simulation. First stage, second stage, third stage and fourth stage. So right now results are not appear, only the formed component is visible here. We will talk on the results at the end of the video, and you can see how beautifully software is able to capture the behavior of the forming component, as you can see in experimentation also. So let me tell you how to perform such analysis in HyperForm. So just open the HyperForm environment. I already opened that HyperForm environment, and here the previous file is already open. So I'm just going to take a new file. First let me close the multi-stage disable, then go for new file. Okay. So if you want to perform the multi-stage analysis, you can perform in two ways. One, already I told in my first and second video how to import formed component or formed blank result for the next stage forming and how to proceed. And here I will go for multi-stage process manager. So to enable the multi-stage process manager, you have to go for here in the user process, and in the user process, see, if I go for perform any analysis directly, it will perform only the single stage analysis. So to enable the multi-stage, just go for here, right click, multi-stage, and check on the enable options. So now you have multiple stages that you can choose, and this is the setup for the multi-stage analysis. So for basic operation we have in the multi-stages, one is the gravity loading, that one is the forming. All type of forming analysis you can choose from here. Trimming, and that is the spring back. So we are not going to perform the gravity loading and trimming and spring back analysis here. We are simply perform multi-stage analysis of a component which is going to be formed or which is going to be draw by 4 stages. So let me choose the stages by double click on this forming. See, in the process sequence one process is added. Similarly I can go for add multiple processes. I need 3 process here. So after calling 4 forming stages, I am saying here forming because the software did not have any specific options for the drawing. We have to perform the forming drawing analysis by forming process itself. So we have 4 drawing sequence, and here also you can see after setup the stage 1, stage 2, stage 3 and stage 4 are added. Okay, if I go for add any further a stage, like I want to go for trimming, just go for double click on the trimming, and here stage 5 will be add. If I want to remove any operation, just right click here and go for delete. So that process will be removed. So to make a setup for the multi-stage process, I have to go for here the first stage, double click on that and go for here stage first. Make sure your icon will be selected on the stage 1. Just go for here stage 1. Okay. So now whatever geometry you are going to import, whatever meshing you will do and any work you will do, that will be for stage 1. Similarly, if you are in the stage 2, so whatever the modeling and meshing is there is only for the stage 2. So look, if I go for stage 1 and just going to import some geometry, either you can go for here import options. If this options is not available, just go for here file, import and import geometry. So this geometry will be import only for the stage 1. Okay, so just go for open the geometry, and here already I have geometries for the multi-stage deep drawing process. So this one is the geometry stage 1 new.igis. just go for open it. Make sure your scale options or scale factor is 1 and click on import. Okay, now again go for multi-stage and check the model. See, I have one component here, but basically I need 4 component actually: punch, die, binder and blank component. So what I'm going to do, I'm going to rename this as a punch. Make sure the shaded mode. Now I'm going to create a new component as die, and again go for creating new component, binder, and last one is the blank. Okay, now let me arrange the geometries for the different component, because right now all geometries available only in the punch component, and you can go for the auto color also. Okay, see the all geometries available in the punch component. Go for shift F11, that is nothing but your organize options, and organize different geometries, different surfaces in the different component. One more thing, that component is right now as a solid. If you want to delete that solid, because I want only the surfaces, just go for F2 and here delete that solid. Okay, make sure the delete bounding surface options is checked off and just go for delete. See, the surface will be remains and solid will be deleted. The other thing, that geometry visualization is not proper. Just go for O from the keyboard options, go for the graphics, and the level is 5. Now the geometry edges are visible properly. So let me organize. Shift F11, select the surfaces, just go for here attached. These all attached surfaces are die surfaces, so move in these surfaces in the die. Similarly, these all surfaces are belongs to binder, just go for move. Okay, so now you can hide your binder as well as die. This surfaces belongs to blank, just go for here, move in blank. Okay, now it's fine. After that, you have to hide your blank component, and you have to mesh all other component by the rigid meshing. So press F12 button from the keyboard. Here go for the rigid body mesh. I always prefer to mesh using auto mesh panel. So here those parameters are quite sufficient, and just go for select the surfaces. Those things are nothing but minimum size of the element, maximum size of the element, maximum deviation. So this is the edge, and if my element will be create here likewise, so what will be the maximum deviation? Let me show you. See, this is the edge and this is the element. So what maximum deviation I am allowing to the software, and the feature angle is nothing that work when you have the curvature or fillet surfaces. Okay, likewise if you go for reducing the feature angle, it will be create here more element. Okay, so those tools are meshed. Now I go for mesh the blank component, and it is very easy to mesh this blank component. Press F12 and make sure you go for size and bias, select the surface and mesh. So 10 is sufficient. Even this is the smaller element size. I am going to increase, otherwise it will take too much time to perform analysis. Okay, So 20 is fine, and we will go for the adaptivity also. So punch, die, binder, those I am going to show. Okay. So now see, again go for the multi-stage, stage 1. So whatever work we did is only for the stage 1. Okay. When I go for stage 2 and go for model, there will be nothing. But if I go for stage 1 and then go for model, there will be some component, because we called the geometries, we meshed the components only for the stage 1. Now go for the stage 2 and do the same work, and similarly for stage 3 and stage 4. So let me do this. Okay, the most important thing, if we are going to perform deep drawing analysis, we did not need binder component further. Okay, so we have only the punch and die component, and the blank component will be the same blank that we got from stage 1. So even for the stage 2, not need to create any blank component. Okay, so initially we need to create the blank component, then we need to create only the punch and die. So similarly, I go for create component for the further stages, and before that I have to mesh my model. Just go for F12, select the surfaces, make sure rigid body mesh, and go for mesh. And even you can go for ideal geometries if you want. So let me do the same for stage 3 and stage 4. So for the stage 4, this is my die component, and this is my punch component. So once you import the geometries and go for cleanup, if you want any cleanup work, and go for meshing, see, just go for multi-stage and go for setup here. Stage 1, so this will be the stage 1 geometry, stage 2, similarly stage 3 geometry, and stage 4 geometry. So once you did all this work, again go for the setup, and you have to make sure the base directory, that is very, very important. Why? Because all the data you created will going to save there. So right click on the base directory, go for set and define the folder. So I'm going to define here the forming folder, and my subfolder is multi-stage tutorial first. So this is my folder. Once you define the base directory, right click on the multi-stage and make sure you save the files. When you hit on the save button, the first stage, second stage, third stage, fourth stage, all stage will be going to save. Okay, and make sure again you have to go for the first stage. Every time you have to go for the first stage to define any new work. Okay, so now you have to go for the setup. So till now only you imported the geometry. Now we are going to define the process parameter, the simulation parameter, as well as drawing parameters. Go for here stage 1. So what type of process you have? See, till now we seen the forming analysis by auto process manager, and here I am going to use little bit different way. So this is the stage 1, right click on the process type, forming, and this one is our double action. So this was the same process. Here also we have double action, and here also we have double action. The double action is nothing but your punch is in above side, die is stable, and we have here binder and blank also. The same condition we have, so that's why I go for the double action draw. So I will tell you those all parameter one by one. After the forming process, you have to go for the animation count. The animation count is nothing but number of animation file that you want to create during the simulation. Okay, so by default those are the 10 file, and I am going to keep as it is. The draw direction is Z direction. Whatever the draw direction, either the positive Z direction, either the negative Z direction, you have to make sure only the direction as Z. Okay, no need to create here -1, otherwise it will create some problem. Okay, the datum is nothing. When I go for the auto position, this options auto position means if we have some different gap or unnecessary gap between tools and blank, so if I go for the auto position, software will automatically adjust that gap. Okay, and it needs some reference with respect to what it need to auto position the different component, or we can say the other component. So that is our the datum component. So by default blank is our datum component. If you want, you can go for define die as a datum component. Okay, the motion mode is nothing but your punch is movable component. So either you can go for decide the movability by velocity or by displacement. So by default it is in velocity, and keep it as it is. The memory, what maximum memory simulation need, that I am going to define as automatic. Adaptivity level, that also I already explained in my previous videos. So I am keeping adaptivity level 2, that is sufficient for the simulation. Thermal options, if you go for performing the thermoforming, then only it need to check on, otherwise keep that options as off. Now we are going to define our blank component, that is very important. So in the blank component, I have to define the blank material. To define the blank material, just right click and go for the database, and here you have material in the database. If you want to create your own material, if you want to create your material into database, for that also I created a separate video. You can go for that video. Likewise here I created two materials like my steel and my CRDQ material. So I am going to choose here my CRDQ cold roll draw quality material and just click on the select button. Thickness, in this case my blank thickness is 1.5. So once blank parameter is finished, and those are the settings, basic settings, simulation settings, you have to go for defining the tool parameters. Those all are the tool parameter. In the tool, first tool that we have is die. Die is stable, so there is no motion condition as well as there is no force condition. Make sure die is in contact with all blank. Okay, so it is already is in contact with all blank. If I go for choose here the double action draw, software will automatically consider the all blanks to be contact with die. Okay, so remains parameter like friction value. If you want to change, you can go for change. Otherwise, no need to change any other parameter for die because die is stable. Now the binder component. Binder also going to be contact with all the blank component with some friction value. The material is tool material. Similarly, for the die also we have tool material. Means it is the rigid. Okay, tool material is nothing but your rigid. It not going to deform. Similarly, one more thing, that position you can decide, and if you go for the user process actually, but we choose the double action draw, so by default the position also choose by the software. Like die will be the below with respect to the blank component, the binder will be above with respect to the blank component. Okay, those all parameter I already explained. So if you have any clearance value, just go for define it. The important thing for the binder component, that is motion of the binder. So don't worry about the distance of the binders. See, in the setting I choose here the auto position on. Software will automatically define whatever distance it need to be keep here. Another important parameter is the velocity of the binder. If binder is in somewhat at above position, with what velocity it will be strike or it will be come toward the blank. So I am going to define here 1000 mm per second. Even 1000 mm also quite high, but if I go for keep that velocity as low, the simulation time will be increased. And the another most important thing here, we have binder force. So there is some thumb rule to calculate the binder force, but I am not going to show you that rules. By default 30,000 is the sufficient binder force here. Same parameter you have to define for the punch, like contact condition, material, motion 1 and motion 2. So what is the motion 1 and motion 2? Those things also I explained in my previous video. So just go for define here velocity as 1000 for the motion 1 and 1000 for the motion 2, and don't worry about the distance, it will be calculated by the software. So this all setting is done, and once this setting has done, you have to move toward the next stage. Okay, just go for here stage 2. The process type we have here crash form. The crash form is nothing, you don't have here binder. Okay, you have only punch, die and the blank component. So the blank component will be import from the stage 1. Okay, whatever stage 1 result we have, the same blank will be import here and auto positioned accordingly. Okay, so there is same parameter I have to decide, and the important thing that is, look, all those parameter I explained, and if you want to go through those parameter again, just go for, and here I want to change only the velocity of the punch, that is 1000 mm per second. Similarly for the third stage, again the same thing, you have to go for here process as crash form. For the crash form, all setting is already defined, and go for define the velocity as 1000 mm per second. And similarly for the stage 4, see, in the stage 4, whatever the blank or whatever the result in the stage 3, those will be automatically called for the stage 4. Okay, so just go for here define the process as crash form, animation count, draw direction, and those all things. And at the last we have here the punch velocity, that should be less as possible, because we consider drawing process as a quasi-static process, and for the quasi-static process loading should be as slow as possible. Okay, so all those stage parameters are defined. Again go for setup, make sure you save the file, right click and hit on the save. See, stage 1 file is saved, 2 is saved, 3 is saved and 4 is saved. Again make sure you double click on the first stage. The two most important thing that I am repeating, you have to select the base directory and you have to save your file. Okay, once you save the file, once you define the tool setup for the all stages, define the parameters, now you can go for the simulate or run your process. So just hit on the run live. It will be asking, you are simulating the behavior from the stage 1. Are you sure? Just hit on the yes button. So you can see here the simulation is started, and solver starts solving the problem and it writing the animation file as per the input parameters. And if I go for check that folder, desktop forming tutorial, see, those 4 folder will be created by the software automatically when you go for save your file. Okay, stage 1, stage 2, stage 3, stage 4, because we have here 4 stage, you have here n stages. And just go for open the stage 1 and see, these are your simulation file like A001, A002 and those all. Complete simulation will take some time to perform. It will took around 1 hour. So I am going to discuss on results. So to discuss on results, I already simulated those behavior in the same manner. So I am going to open the results again. Just go for here, add new page. Just go for open model, open your file. See, this is my previously simulated results, multi-stage new, stage 1. Go for open the S3D file. Go for apply. Make sure you hide your rigid elements, and die component should be transparent that you can see the blank component during its manufacturing process or during its animation. And other thing that I'm going to hide the binder also. Okay, sometimes those options you may not have. See, the second process, or we can say second stage simulation is started. Okay, so sometimes if you don't have these options, just right click here and go for configure browser, and here you have column options and check on those things like FE style. If you checked off this options, this finite element style will be checked off. Similarly, color, info, ID, those all things you can check on and check off. Just go for check on this and go for OK. So similarly, I want to open the other stages results in the same window. So just split your window into 4 halves. Go for some standard view. Go for here and open second stage result. Hit on apply button. Similarly, third stage result in the third screen. And last final stage results, just go for stage 4 and S3D file. Okay, so those results are imported, and just go for some standard view. Likewise, make sure you off this option synchronize window, and now you are able to move each component or each tool individually. Those red things are nothing but your rigid element, and we are going to hide those rigid element for the every model. And similarly, I am going to make sure the die as a transparent, that forming of the blank should be visible. Okay, same for the all components. If I go for simulate this, just click on the simulation button here. The all 4 process will be simulated at a time. Look, this is the stage 1, stage 2, stage 3 and stage 4. If you want to simulate those things in sequence, you have to go for here in the setting and go for time scale options. In the time scale options, go for synchronization control, edit for scale and offset, and here you have editing options. Like I want to offset the simulation 2 or window 2 with time as 0.1. Similarly, see here you can see the total time for the simulation stage first. So it is approximate 0.09 second, or we can say around 0.1 second. Okay. Similarly, you have to add this time with this, and you can delay the stage 3rd simulation. Okay. So the total time will be 0.1 and 0.16, that will be 0.26. I'm keeping as 0.27 around, and this one is the 0.17. So for that I'm going to define as 0.45 offset. So just hit on the apply button. Now if I go for simulate, it will be simulate in the sequence. Okay, so in this way you can simulate any results in the sequence if you have multiple results. First stage result, second stage result, third stage result, and those 4 stage results. Now we will talk on the forming results. So just go for here, synchronizing the windows, and make sure a standard view likewise. And I'm going to hide the other all components. I'm going to check on only the blank. Similarly, die and punch I'm going to hide. Contour options, and make sure the thinning for this component, and click on, see here, go for the thinning, averaging option simple, and go for apply. So for the first stage, thinning percent is only 3.5%. So results are quite acceptable for the drawing process. And similarly, we are going to visualize the result for the all other stages. Just go for here, thinning, simple, and OK. Here the thinning percent is little bit high. We will see why this thinning is moving high. Similarly for the third stage, and similarly for the fourth stage. The most important thing that you have to concentrate, those results, thinning results, are not going to be added in the average step. This thinning is the individual thinning result. Okay, this thinning means you can say here the 3.5% thinning result we are getting here, and here we are getting 10% thinning, here we are getting around 11% thinning, and here we are getting only 9.9 and the 10% thinning in the individual stage. Okay, not in the combined stages. So the result for the thinning is not available in the combined stages, but if you want to see a combined result of the all stages, you have to go for here the thickness option. Just go for thickness options and apply. See, whatever thickness result will be here for the first stage, they will be added for the further stages. So I click and apply style on the current pages, all selected. We checked on all the other components. Just go for check off. Let me go for here. At the beginning of the simulation, there is no change in the thickness for the sheet component. The complete sheet will be having the same thickness, that is 1.5, and you can verify from here also. The result is in between these two. Okay, 1.48 to 1.5. This is exactly 1.5. Okay, so but here for the second case, the initial blank having some thickness, and this is the third stage simulation is started. I'm going to minimize this. So what I'm saying here, for the stage 2, whatever result we are getting in the stage first, okay, those result as it is exported, and then simulation will be start. See, this is the first stage, and here we are getting the red thing is nothing but your wrinkling actually, and this blue is representing the minimum thickness. Minimum thickness means here we are getting the thinning. Okay, so see, even this process is not started, second stage even not started, but still we are getting some results here. Why? Because the previous stage simulation result are exported here. Similarly, after second stage, see, this is the second stage, and after this second stage, whatever result we are getting, those results are exported for the third stage. Okay, even the third stage process is not started. Now it is started, and similarly the third stage result will be exported for the fourth stage. So the fourth stage will be represent here the overall thickness. Okay, so or we can say the final manufactured component thickness. And if I go for make it zoom, and you can see here is the thinning zone, and this thinning is nothing but my sheet thickness is 1.5, and minimum thickness for the final component we are getting 1.3, and this is the wrinkled zone. Okay, and the maximum wrinkling that we are getting is 2.27, and this wrinkling is only on those particular zones. Okay, if I remove this particular zones, these zones, my wrinkling is around, or we can say the maximum sheet thickness is around 2 mm only, and this wrinkling is appear due to the tool design error. Actually, I am not very good in the tool designing. I make all those tools manually according to the research paper, whatever parameters given in the research paper. So see, I will tell you here in the stage 2, I go for stage 2 and go for here expand. In the stage 2, I am going to check on those punch and die and make sure die is your transparent, and going for top view. Okay, hiding the punch component, it is not necessary. See, I am going to process this manually, and you can see here after particular limit there is sudden wrinkling. See here, there is sudden wrinkling in the component, and this wrinkling should be avoided. Either we have to change the tool parameters, or we have to make process more slower, that may we can eliminate the wrinkling. Okay, so due to this particular behavior at this end, or we can say at this stage, see, you can clearly see there is a wrinkling, and due to that wrinkling, what happening, the sheet is going to be overlap. Okay, so that's why we are getting too much wrinkling on those particular zones. these are the final manufactured component: initial blank, first stage, second stage, third stage, and fourth stage. So you can see here burrs are visible at the end of the component, and same burrs also visible here also. So you can see how beautifully software is able to capture those behavior. See those burrs. The another thing is the thickness value. So this solution for the research paper is done in the abacus, and for the finding the thickness they plot a graph. So here we don't need to plot a graph. See, this is the thickness results. For the first stage, the minimum thickness is around 1.4 and the maximum thickness is around 1.7. So let me show you the first stage result. This is the first stage result here, and see, so it is around 1.44, very close, and same here 1.7, the highest thickness. 1.7 is highest thickness. And for the second stage result, here the thickness results are most important. For the second stage, if we ignore this particular result, this results, okay, why? Because we are getting here the higher thinning due to the tool design error. Okay, so I'm going to ignore this error. So other results are within the yellow limit, and this yellow limit is up to 1.97, or we can say 2 mm. Okay, so we have thickness, minimum thickness as 1.3 and maximum thickness as 1.9, or we can say 2 mm. So same for the stage 2. The minimum thickness is around 1.37. Similarly, here we are getting minimum thickness 1.34, very close, and the maximum thinning we are assuming here for the most of the zones is 2 mm, or we can say 1.9, and this is also a little bit far but quite accurate. Okay. Similarly, for the stage 3, let me show you the stage 3 result. Just go for here. So similarly for the third stage, just go for zoom in the third stage and go for here, stage 3 result. Minimum is 1.35 around and maximum is 1.8. So you can see here 1.35 or 1.33. Maximum, we are ignoring this result, so it is around 2 mm. And same for the fourth stage. Minimum is 1.3 and maximum is 1.8. So just go for here. There is some graphical error. Just go for clear contour here, because see, minimum thickness is representing as 0.1. So just go for here, display, result, clear contour, and again plot the results. Just go for here, thickness value, simple, select the component and go for apply. Now results are accurate. Okay, so for the fourth stage we are getting the minimum thickness as 1.3, quite accurate, and maximum thickness, again the yellow region we are assuming here as a maximum thickness, and that is around 1.9 or 2 mm. So it is also quite close. In this way you can see the forming results are quite close to the research paper, and even if you want to plot a FLD curve, you can go for it. But this video I am not going to make more lengthy, so let me finish here. So I suggest to go for the previous video tutorial that you can understand this video tutorial more precisely. So hope you are getting a clear idea how to perform multi-stage analysis for the deep drawing process, that is via multi-stage process manager, and previously I also told manually. So now you are able to perform multiple stage simulation, or we can say forming simulations. Either they are considered as a drawing or either they are considered as a forming. So thank you for listening.